If we find anything alive on Mars, even something microscopic, even ancient, that is the day the odds of human extinction go up. Not because Martian life would be dangerous, not because of contamination or invasion or anything that belongs in a film, because of what it would mean, because of what it would tell us about where we stand in a universe that has been running for 13.8 billion years and that, so far as every instrument we have ever pointed at it can determine, contains exactly one civilization capable of asking what it is looking at. Us. That number one is the thing this is about. And before this is over, you will understand why every positive result in the search for life beyond Earth, every biosignature, every wet moon, every organic molecule drifting through a nebula is not good news. Why the correct emotional response to discovering that the universe is full of life is something closer to dread than wonder. Why Enrico Fermi's casual lunch table question has assembled, in the 75 years since he asked it, into an answer that most treatments of this subject approach and then quietly turn away from. This one doesn't turn away. The Mars thought experiment is where we start, because it is the cleanest version of the argument. Suppose we send a probe, and it finds microbial life ancient, frozen, dormant for millions of years, but unmistakably biological, unmistakably the product of chemistry organized by evolution. The world reacts with euphoria. We are not alone. Life is out there. The universe is alive with possibility. That euphoria is wrong. What the discovery actually tells you is this: life can emerge independently on a rocky planet with water and energy. Mars had those conditions early in its history. If life emerged there separately from Earth, it means life emergence is not the nearly impossible step that explains why the galaxy is empty of civilizations. The filter, the thing that stops civilizations from arising or persisting, must be somewhere else. And since the galaxy is still silent, since there are still no signals and no megastructures and no evidence of any civilization that made it to the stars, the filter being somewhere else means it is somewhere between where Mars's life stopped and where we are. Or somewhere between where we are and where we would need to get to. Every step you can rule out behind you is another step that must be ahead of you. Hold that. We will come back to it. First, the silence itself, because the silence is not nothing. It is, specifically and precisely, what the universe would look like if something is stopping civilizations before they can fill it. Nick Bostrom is a philosopher at Oxford. He works on existential risk, the kind of risk that doesn't give you a second attempt. In 2008, he wrote an essay called "Where Are the Aliens?" and in it he made an argument that is, by any measure, one of the most counterintuitive results in the serious literature on this question. He argued that the discovery of any life beyond Earth, any life, anywhere, at any level of complexity, would be, in his precise words, by far the most terrifying news in human history. Not exciting, not historic, terrifying, and he was right. And the reason he was right is the reason this entire subject is harder than it looks from the outside, harder than the documentaries suggest, harder than the wonder framing of SETI's public face has ever quite admitted. The reason lives inside a piece of logic that, once understood, does not let go. It is called the Great Filter. And understanding what it is, where it came from, and what it actually says about our position in the universe is the only way to understand why the silence of the cosmos is not a puzzle waiting to be solved. It is a verdict waiting to be read. Start with what we know. The universe is approximately 13.8 billion years old. The Milky Way galaxy alone contains somewhere between 200 billion and 400 billion stars. The fraction of those stars with planets is now understood, after decades of telescope data, to be very high. Most stars have planets. And a substantial fraction of those planets sit in what astronomers call the habitable zone, the orbital range where liquid water can exist on a surface. Conservative estimates put the number of potentially habitable planets in our galaxy alone in the billions, and the Milky Way is one of roughly 2 trillion galaxies in the observable universe. These numbers are not controversial. They come from the Kepler Space Telescope, from radial velocity surveys, from transit photometry, from observations, not speculation. The universe is, by any reasonable accounting, enormous, old, and full of the conditions that on Earth produced life within the first billion years of the planet's existence. Earth is not a special case in terms of its basic physical parameters: rocky planet, liquid water, energy from a star, organic chemistry. Those ingredients are common, staggeringly common. So where is everybody? That question was asked at a lunch table at Los Alamos National Laboratory in 1950. The person asking it was Enrico Fermi, who had built the first nuclear reactor under a squash court in Chicago, helped design the bomb that ended the Second World War, and was by any measure one of the most capable physicists of the 20th century. He was not asking it as a research program. He was asking it because someone had made a joke about a cartoon, and the question followed naturally. And Fermi, being Fermi, did the quick math in his head and found that the math didn't close. The universe should be full of civilizations. The timeline allows for it easily. So why, when we look up, is there nothing? That is the Fermi Paradox. The famous version, the one that ends with a question mark. The famous version is not wrong, but it is incomplete in a specific way. It frames the silence as a mystery, as something that future discovery will resolve, that better telescopes or longer listening or more sensitive receivers will eventually answer. The frame implies the answer is out there waiting, and that implication, comfortable, open-ended, allowing for hope, is what the actual evidence does not support. The actual evidence supports something else. To understand what, you need the Drake equation. Frank Drake was 29 years old when he wrote it on a blackboard at the National Radio Astronomy Observatory in Greenbank, West Virginia, on November 7, 1961. He wrote it to organize a meeting, the first serious scientific gathering devoted to the search for extraterrestrial intelligence, and he has said, in interviews conducted decades later, that he did not think of it as an equation in the serious mathematical sense. It was an agenda, a list of things we didn't know, arranged in the form of multiplication. The equation looks like this: n, the number of communicating civilizations in our galaxy right now, equals the rate of star formation, multiplied by the fraction of stars with planets, multiplied by the fraction of those planets that are habitable, multiplied by the fraction of habitable planets where life actually emerges, multiplied by the fraction of life-bearing planets where intelligence emerges, multiplied by the fraction of intelligent civilizations that develop detectable technology, multiplied by the average lifespan of such a civilization in years. Some of those terms we now know reasonably well. The rate of star formation in the Milky Way is roughly 3 new stars per year. The fraction of stars with planets, high, probably above 50%. The fraction with habitable planets, lower but not negligible, perhaps 20% of Sun-like stars. Those first terms are constrained by data. They are not the problem. The problem is the terms in the middle and at the end. The fraction of habitable planets where life emerges. The fraction of life-bearing planets where intelligence emerges. The fraction of intelligent species that develop radio telescopes. The lifespan of a technological civilization. Those terms are not constrained by data in any meaningful sense. They are constrained by hope, or by pessimism, or by whatever prior the person filling them in brings to the table. This is where the famous version of the story gets complicated. When Carl Sagan filled in those terms in the 1970s and 80s in his books, in his television series, in his public lectures, he was generous. He estimated that life emerged on most habitable planets. He estimated that intelligence was a likely outcome of evolution. He estimated that technological civilization was common. He arrived at numbers suggesting millions of communicating civilizations in the Milky Way. And he said so, publicly, repeatedly, with the full force of his considerable credibility and his extraordinary gift for communication. What Sagan's estimates required was the assumption that every uncertain step went well. Life emerges easily. Intelligence follows. Civilization follows intelligence. Communication follows civilization. Civilizations last a long time. Every uncertain term was resolved generously. Not dishonestly, the terms genuinely were uncertain, and generosity was a defensible position. But generosity was also the position that kept the enterprise alive. SETI needed public funding, congressional support, sustained interest from the scientific community. None of those things were easy to maintain. The history of SETI's funding is a history of near-death experiences, congressional ridicule, budget cuts, near cancellation. In that environment, the optimistic estimate was not just intellectually defensible. It was professionally necessary. The pessimistic estimate, the one that takes the silence seriously as information, that asks what the universe would have to look like for the silence to be consistent with life being common, did not help anyone's funding case. It did not generate wonder. It did not produce the kind of excitement that sustains a long-term search. And so it did not get the PBS special. But it was available. The math was always available. And in 1998, an economist in Fairfax, Virginia, ran it. Robin Hanson was not a member of the SETI community. He had no telescope. He had no NASA grant. He was a researcher in economics and decision theory at George Mason University, interested in the long-run future of humanity, in the kind of question that economists approach differently from physicists. Because economists are professionally required to think about expected value without letting hope distort the calculation. He looked at the Drake equation and he saw something that the astronomy community had, for institutional reasons, not said plainly. If the universe is as old as it is, and as large as it is, and if the conditions for life are as common as they appear to be, and if intelligent life were even moderately probable given those conditions, then the evidence we should expect to see in the night sky is not silence. It is activity, colonization, Dyson spheres, the signatures of civilizations that have been expanding for millions of years. Even a single civilization that arose 1 billion years ago and expanded at a fraction of the speed of light would have filled the observable galaxy by now, several times over. The silence does not just mean we haven't found anyone. It means that in the entire 13.8 billion year history of the observable universe, no civilization has done what a civilization with enough time and technology would naturally do. The silence is a constraint, a hard one, and a hard constraint on the frequency of civilization requires that something, somewhere in the chain from chemistry to communication, is extraordinarily difficult. Difficult enough to have stopped every other attempt. Difficult enough to be, in Hanson's term, a filter. He called it the Great Filter. The paper The Great Filter, Are We Almost Past It?, went up on his faculty webpage in 1998. No journal, no press conference, a webpage. It was read by everyone who eventually mattered to this question, and it changed the shape of the conversation, and Hanson received no particular recognition for it from the SETI community, because the SETI community was not in the business of publishing findings that argued against the plausibility of their own enterprise. The Great Filter did not go away. Here is what the Great Filter argument actually says. Somewhere between dead chemistry and a civilization broadcasting radio waves across the galaxy, there is at least one step that almost never succeeds. We know this because if it succeeded regularly, the galaxy would be full of civilizations, and the galaxy is not full of civilizations. The silence proves the filter exists. That is not speculation. It follows directly from the data, from the fact of the silence itself. The only question that matters, is where the filter is. There are two possibilities, and they lead to completely different conclusions about what we are and what is coming for us. Possibility 1, the filter is behind us. It was in our past. The difficult step, the nearly impossible step, was something that we have already cleared. The emergence of life from chemistry. The leap from simple cells to complex cells. The emergence of multicellular life. The development of a nervous system capable of abstract thought. Any one of these transitions, or some combination of them, might be the great improbability. If so, we are extraordinarily lucky. We are what made it through. The universe is empty not because civilizations get destroyed, but because getting to us is so hard that it has only happened once, or nearly once, in the entire history of the observable cosmos. We are the miracle. And ahead of us, all possibility is open. Possibility 2, the filter is ahead of us. The difficult step is something we have not yet faced, something that technological civilizations encounter and do not survive. Nuclear war, engineered pandemic, climate collapse, something we cannot yet name or imagine, something that every civilization, or nearly every civilization, runs into and fails to clear. If so, the silence is not a record of how hard it is to get to us. It is a record of how few of those who got to us made it further. The galaxy is not empty because life is rare. It is empty because civilizations are temporary, and we are approaching the filter right now. Those are the two possibilities. They are not equally comfortable, and they are not equally supported by every piece of evidence we add to the ledger. This is where you need to understand why the alternatives, the hypotheses that the serious literature generates to explain the silence without invoking the filter, are less well supported than they appear. There is a hypothesis that takes comfort in the idea that the aliens are out there, just not communicating with us. Maybe they are using technology we cannot detect. Maybe they decided long ago that contact is inadvisable. Maybe they are observing without interfering. The zoo hypothesis. The dark forest. The idea that advanced civilizations deliberately suppress their signatures. These are real hypotheses. They deserve honest treatment. The zoo hypothesis that there are civilizations out there that have decided to leave us alone has a problem its proponents do not always address directly. It requires every civilization that has ever reached technological maturity to have made the same decision. Not most of them, all of them. Because it only takes one civilization out of billions of possibilities to decide it wants to make contact, or to leak a signal accidentally, or to have a dissident faction that breaks from the consensus. The zoo hypothesis requires a perfect, universal, sustained agreement across every civilization in the universe for billions of years. That is not epistemic humility. It is a requirement the hypothesis needs in order not to be falsified. And needing something in order not to be falsified is not the same as evidence for it. The dark forest hypothesis, advanced by Chinese science fiction writer Liu Cixin, in a way that has since entered the serious literature, holds that the universe is silent because every civilization that reveals itself gets destroyed by others who cannot afford to take the risk, hide, or be killed. The result is silence by mutual terror. This is more interesting than the zoo because it requires only a local decision rather than a universal consensus. But it carries its own weight. It requires that the universe be full of civilizations capable of destroying each other across interstellar distances, which requires that many civilizations have survived long enough and developed enough technology to pose a credible threat. That full universe is exactly what the silence argues against. The dark forest needs a crowded cosmos to produce an empty-looking one. We have no evidence of the crowded cosmos. The technology we can't detect argument sounds like epistemic humility. Who are we to say what advanced civilizations do? But consider what it fails to account for. The argument is that civilizations advance beyond radio and use something more efficient. Fine, but this applies only to intentional signals. A civilization that has been in space for 1 million years and is building structures around stars is not producing a signature that depends on their communication technology. It is producing gravitational signatures, infrared signatures, changes in stellar behavior visible across tens of thousands of light years. The Fermi Space Telescope looked for gamma-ray signatures of advanced civilizations. The Kepler telescope data has been mined for anomalies in stellar light curves that search produced the famous alien megastructure star, KIC 8462852, which turned out to have a mundane explanation involving dust. The silence is not about radio signals specifically. It is about every detectable signature of large-scale activity. and the universe produces none of them. These alternative hypotheses are not impossible. They are less well supported than the alternative that the silence is an accurate reflection of reality. And in science, less well supported is the thing that matters. With the alternatives examined and set aside, we return to the filter, and to the question of where it sits. The candidates for a filter behind us are the steps in our past that were genuinely difficult, genuinely improbable, and that could explain why the galaxy is otherwise empty. The first candidate is the origin of life itself, abiogenesis, the step from organic chemistry to self-replicating biology. On Earth, this step happened relatively quickly. The Earth is approximately 4.5 billion years old. The oldest evidence of life dates to roughly 3.7 to 4.1 billion years ago. That means life emerged within the first few 100 million years of the planet being cool enough to support it. Geologically speaking, almost immediately. The speed of life's emergence on Earth has been used to argue that abiogenesis is not the filter, because if it were extremely difficult, we would expect it to have taken much longer. But this argument has a problem. It suffers from selection bias. We can only observe the emergence of life from a planet that produced observers. We cannot observe the cases where life failed to emerge, because those planets produced no one to observe them. The fact that life emerged quickly on Earth tells us something about Earth, but it cannot straightforwardly tell us about the general probability of abiogenesis, because we are necessarily sampling from the distribution that includes us. Abiogenesis might still be the filter. The chemistry is genuinely not understood. We have not synthesized life from scratch in any laboratory. We do not know the specific sequence of steps, the specific conditions, the specific improbabilities involved. The origin of life is one of the most genuinely open problems in science, not the kind of open that means we are close, the kind that means we do not have a convincing mechanism. If the specific conditions for abiogenesis are extraordinarily rare, not just a wet rocky planet, but some combination of chemistry and physics that almost never co-occurs, then the filter might be there. Life might be the miracle. The second candidate is the eukaryotic cell. Simple cells, prokaryotes, bacteria emerged relatively quickly on Earth. Complex cells, eukaryotes, cells with a nucleus and mitochondria, with the internal structure that makes multicellular life possible, took roughly 2 billion years longer. 2 billion years. And the transition happened only once. Every complex organism on Earth, every animal, every plant, every fungus, descends from a single eukaryotic ancestor. The evidence suggests it was a specific, unlikely event, a merger between two different types of cell, one of which was absorbed by the other and became the mitochondrion. That merger may have been extraordinarily improbable, and without it, life on Earth would have remained bacterial forever. Intelligent civilization requires multicellularity. Multicellularity requires the eukaryotic cell. If that merger was a near impossible fluke, and the fact that it happened only once in 4 billion years of Earth's history suggests it might have been then, it is a serious candidate for the filter. The third candidate is the emergence of intelligence itself. Not nervous systems. Fish have nervous systems, but the specific kind of recursive, abstract, symbolic intelligence that produces technology. On Earth, only one lineage ever produced it, ours. In hundreds of millions of years of complex animal life and dozens of lineages of large-brained social long-lived mammals, exactly one species developed the capacity for language, mathematics, and fire. That fact is strange. It suggests that human-type intelligence is not a natural endpoint of evolution, not a thing that happens reliably given enough time and complexity, but something contingent and rare even after you have multicellular animal life. These are the main candidates for a filter in our past. Any one of them could be it. More than one could be involved. The filter might not be a single step, but a series of steps, each of which is improbable, the combination of which is vanishingly rare. If any of these is the filter, then the universe is empty, not because civilizations fail, but because civilizations are almost never born. We made it through something extraordinarily hard. The galaxy is ours, eventually, if we can manage not to destroy ourselves. That is the best possible reading of the situation. It is not comfortable being cosmically alone, is not comfortable, but it is survivable. It is a universe in which our future is open. Now the other side. The candidates for a filter ahead of us require thinking about what a technological civilization, once it arises, is capable of doing to itself. Not with the optimism of a species that would prefer to believe it will manage, but with the cold accounting of someone looking at the track record and the trajectory. Nuclear weapons are the most obvious candidate. The discovery of fission took roughly 50 years from the first theoretical understanding of the atom to Trinity, the first nuclear test in July 1945. We built the capability to end industrial civilization within half a century of understanding the basic physics. The Cold War brought us close to using it, more than once, in ways that only became fully public decades later. The Cuban Missile Crisis is the famous case. Less famous, Stanislav Petrov, a Soviet lieutenant colonel, sitting alone in a bunker outside Moscow on September 26, 1983, watching a warning system tell him that 5 American missiles were incoming. His protocol was to report it up the chain. He decided, without authorization, that it was a false alarm. He was right. It was a software glitch caused by a rare alignment of sunlight and satellite sensors. Had Petrov followed protocol, the Soviet response would have been automatic. One person, one decision, one night. The nuclear filter is real. Whether it is the great filter depends on how reliably technological civilizations avoid using what they build. The record on Earth is mixed. We have not had a nuclear exchange. We have come close several times. The preventing, in most cases, involved specific individuals making decisions that history has no way to guarantee. Biological weapons are a second candidate, and in some ways a more alarming one. The reason is accessibility. Building a nuclear weapon requires industrial infrastructure, rare materials, enormous engineering resources. The Manhattan Project cost the equivalent of roughly $23 billion in today's money and employed 130,000 people. A state-level enterprise. By contrast, the tools required to engineer a pathogen are becoming cheaper, smaller, and more widely available every decade. The same advances in biotechnology that allow us to develop vaccines and treat genetic diseases also reduce the barriers to creating something designed to spread and kill. The specific concern is not a state actor with a bioweapons program. Those exist and are dangerous, but a small group, or eventually a single person, with access to synthesis technology and enough knowledge to cause a pandemic engineered for lethality rather than one that emerged naturally and therefore has some natural ceiling on its mortality rate. Natural selection does not optimize for killing all hosts. An engineered pathogen has no such constraint. The design space for catastrophic pathogens is large, and the tools to explore it are becoming more accessible in ways that do not follow the same non-proliferation logic as nuclear weapons. Artificial intelligence is a third candidate, and possibly the most uncertain one in terms of mechanism. The concern, made seriously by people who understand the technical landscape, is misalignment. The possibility that a system optimized to pursue a goal will pursue it in ways that are not consistent with human survival if human survival was not explicitly part of the optimization target. This is not a matter of malice. A system that is very good at achieving goals has no built-in reason to protect things that were not included in its goal. Humanity would not be destroyed out of hatred. It would be sidelined out of the same indifference with which a corporation destroys a habitat as a side effect of optimizing for something else. Whether AI represents a great filter mechanism depends on questions that are genuinely unresolved. Whether advanced AI is achievable, whether alignment is solvable, whether the window between capable and aligned is narrow enough to matter. Climate change is a fourth candidate. Not because climate change will end civilization in the direct sense, but because it interacts with every other filter candidate. It destabilizes food systems, which destabilizes governments, which reduces the international cooperation required to manage nuclear weapons and biosecurity. It generates refugee crises that increase political instability. It increases the probability of state failure in regions where state failure produces the worst outcomes. Climate change is not a single filter. It is a force multiplier on every other failure mode. Any of these could be the filter. More than one might be. And the silence, the hard, sustained, instrument-confirmed silence, is telling us that at least one of them, or some combination, is extraordinarily effective. Effective enough to have prevented any civilization in our observable universe from reaching the point of detectable, durable, galaxy-spanning presence. Now return to the Mars thought experiment. Hold it here and feel what it actually implies. If we find microbial life on Mars, life that arose independently, then abiogenesis is probably not the filter. The basic chemistry works. Life gets started. Fine, now where is the filter? It is somewhere between single-celled life on Mars and a civilization that builds radio telescopes. That range is now confirmed as the range the filter must occupy. If we find complex life on Mars, multicellular organisms, anything with differentiated cell structures, then the filter candidates narrow further. Eukaryotic transition? Probably not the filter either. The complex cell happened. Where is the filter now? Somewhere between multicellular life and civilization, which means it might be the emergence of intelligence. Or it might be what civilizations do with technology once they have it. If we find ruins on Mars, the remnants of a civilization that arose and collapsed before ours existed, then we have our answer. The filter is ahead. Something that civilizations encounter, they do not survive. And we are a civilization. Each positive result is a narrowing. Each narrowing makes the ahead of us position more likely. The euphoria at each discovery is, from the perspective of honest accounting, exactly backwards. This is the structure of the argument. It runs against the emotional logic of discovery. Every time someone announces a biosignature in an atmosphere, organic molecules in a nebula, signs of water on a moon, the public response is excitement. The scientific response, run honestly, should be something closer to a sharp, quiet recognition that the range of places the filter can hide has just contracted. Bostrom made this argument in 2008, and it was correct. It remains correct. And it is still, in most public treatments of astrobiology, not said plainly. It is worth staying with the silence. Because the silence is not nothing. It is very specifically what it would look like if the great filter is real and effective. The SETI program has been running in its modern form since 1960. More than 60 years of listening. The surveys have improved by many orders of magnitude. Early searches could only monitor a handful of frequencies. Modern surveys scan billions. The range has extended from the nearest stars to distant galaxies. The sensitivity has improved to the point where we could, in principle, detect the kind of signal that our own civilization has been leaking into space for a century at distances of dozens of light years. The result is silence. Not partial signal, not noise that might be something. There is the famous WOW signal, detected on August 15, 1977, by Jerry Amon at the Big Ear Radio Telescope at Ohio State University. Amon was a volunteer. He was reviewing computer printout, actual paper printout from the previous night's observations. He found a signal so strong, so narrowband, so perfectly matched to the frequency that hydrogen produces, that he circled it in red pen and wrote WOW in the margin. The signal lasted 72 seconds, which was the length of time any fixed point in the sky could stay in Big Ear's field of view. It has never been detected again. 49 years of follow-up observation. Nothing, nobody has been able to rule out that it was natural, a hydrogen cloud, a satellite reflection. What everybody knows is that it did not repeat, and a civilization trying to communicate would repeat. A lighthouse sweeps. It does not flash once and go dark. Beyond the WOW signal, the record is clean. No repeating signals of artificial origin, no structures around stars that shouldn't be there. The Fermi Space Telescope looked for gamma-ray signatures of advanced civilizations and found nothing. The Breakthrough Listen project, funded by Yuri Milner, the most serious modern SETI effort by orders of magnitude, has surveyed millions of stars with extraordinary sensitivity. As of now, the result is consistent with what it has been consistent with since 1960. A universe that does not contain civilizations broadcasting in ways we can detect at the scales we have searched. The people running Breakthrough Listen know the great filter argument. They are running the search because it is the right thing to run, because the alternative, which is to decide in advance that the answer is negative and not look, is not science. Science looks. Science reports what it finds. So far, it has found nothing. Now here is something the inspiring version of this story never quite accounts for. The telescope that recorded the WOW signal, the one candidate signal in 6 decades of systematic listening, was torn down to make way for a golf course. Ohio State had been trying to defund Big Ear for years before it finally succeeded. The telescope was a cost center. It was eliminated. The question of where everybody is has been answered, if it has been answered, from a radio telescope that printed its data on paper and was eventually replaced by a golf course. That is the actual history, not the inspiring version, the actual one. The inspiring version is not false. The inspiring version is Sagan on television, explaining the Drake equation to a country that was ready to believe the universe was full of minds like ours. The inspiring version is Drake at the Green Bank blackboard, giving the question a form that allowed people to reason about it. The inspiring version is the Voyager Golden records the disks attached to the Voyager 1 and 2 spacecraft, launched in 1977, carrying sounds and images of Earth into interstellar space on the theory that someday someone might find them. Voyager 1 is now approximately 24 billion kilometers from the Sun, traveling at approximately 17 kilometers per second. At that speed, it will reach the vicinity of the nearest star in approximately 73,000 years. It will not reach that star. It is traveling in the wrong direction, a direction determined by the geometry of a planetary sightseeing tour in the outer solar system. The Golden Record on Voyager 1 contains greetings in 55 languages, music from various human cultures, sounds of rain and surf and animal calls, images encoded in a format a technically sophisticated civilization could decode. It was designed by a committee chaired by Carl Sagan. The odds of any civilization ever finding it, given the scale of interstellar space, are so small as to be essentially zero. The Golden Record is out there, drifting, carrying the sounds of Earth into a darkness that, so far as we can determine, is empty of anyone who would know what to do with them. The silence is not absence of evidence in the trivial sense. It is evidence of absence. There is a difference, and it matters. If you search a room carefully and find no elephant, that is evidence that there is no elephant in the room. The quality of that evidence depends on how carefully you searched. 6 decades of SETI, covering the frequencies and ranges it has covered, is not a casual look around the room. It is not conclusive the universe is large, but it is consistent with, specifically and precisely consistent with, a universe in which civilizations capable of detectable technology are extraordinarily rare or do not persist. There is a specific calculation worth doing. How long would it take a civilization to spread across the Milky Way at a small fraction of the speed of light? The Milky Way is approximately 100,000 light-years in diameter. At 1% of the speed of light, technologically ambitious, but not physically impossible, it would take roughly 10 million years to cross from one side to the other. Against the 13.8 billion year age of the universe, that is less than 0.1%. A civilization that arose 1 billion years ago and began spreading would have had 100 times the required duration to fill the galaxy, several times over. 1% of the speed of light is not science fiction. The Breakthrough Starshot project aims to send a gram-scale probe to Alpha Centauri at 20% of the speed of light using laser sails. 20%. The scale up to a civilization-founding vessel is enormous, but the principle is constrained only by engineering, not physics. A civilization with 1 billion years of head start would have left signatures visible from Earth with instruments we already have. Not through intentional communication, but through their unavoidable footprint. their energy use, their construction, their sheer presence. There is no such footprint. The physicist Michael Hart analyzed this in 1975 in a paper called Explanation for the Absence of Extraterrestrials on Earth. Hart's argument was direct. If they existed and had the time, they would be here. They are not here. Therefore, in all probability, they do not exist in a form capable of interstellar expansion. Hart's conclusion was the clearest statement of the case for the Great Filter before Hansen named it. More recent work by Anders Sandberg at the Future of Humanity Institute at Oxford has formalized the constraint. The number of civilizations required for we should expect to have found them by now is not large. One civilization, arising anywhere in the galaxy more than 100 million years ago and capable of interstellar travel at any plausible fraction of the speed of light, would suffice. 1. The fact that we see none means that in the entire history of the Milky Way, no such civilization has arisen, or that it arose and failed before it could spread, or that something prevents civilizations from spreading even when they reach the capacity to try. Any of those conclusions is consistent with the Great Filter. None of them are consistent with the universe being full of long-lived expanding civilizations. Stay with the number for a moment. 1. That is the number of civilizations in the observable universe that we have confirmed. 1. Us in 13.8 billion years, across 2 trillion galaxies. We are one data point. From one data point, you cannot derive a general rule. You cannot say, civilizations always emerge, or civilizations always fail. From one data point, you can say nothing general at all. This is the correct epistemic position, and it is also a deeply uncomfortable one, because it is compatible with both possibilities simultaneously. We might be the one civilization that made it through an extraordinarily difficult birth. We might be the one civilization that is about to fail for the same reason every other one did. One data point cannot distinguish between them. What the broader data, the silence itself, does is constrain the distribution. It says, whatever the truth is, it must be consistent with a universe this quiet. A universe this quiet is not consistent with intelligent life being common and long-lived. It is consistent with intelligent life being rare, or short-lived, or both. Rare and long-lived, filter behind us. Common and short-lived, filter ahead of us. Rare and short-lived, both, which is the worst possibility, and which the silence does not rule out. These are the shapes the answer can take. None of them are the shape the popular version implied: the universe is full of life. We just haven't looked hard enough yet. The answer is coming. The wonder is justified. The wonder might be justified, but it needs to be a different kind of wonder. The kind that does not require the universe to be full of others. The kind that can survive the universe being empty and still find that remarkable. Still find us remarkable. Still find the fact that chemistry became biology, became complexity, became language, became this question, still find that worth something. The wonder that survives the silence is not the wonder of company. It is something older, more exposed. Here is what Robin Hansen's paper said that nobody wanted to hear. It is not enough to know that the filter exists. You need to know where it is, and the way to learn where it is to look at what we know about each step in the chain from chemistry to civilization and ask, is this step well understood? Is there a mechanism? Is there evidence that it happens readily? For some steps, the answer is yes. Chemistry produces organic molecules readily. We find them in space, in comets, in the atmospheres of planets we have never visited. The basic ingredients are common. For some steps, the answer is maybe the emergence of simple life is not understood, but its speed on Earth is at least consistent with it not being impossibly rare. For some steps, the answer is no, the eukaryotic transition, the emergence of language, the development of the specific suite of traits that produced technological civilization. These steps are not well understood. They did not repeat on Earth in other lineages, even though there was abundant time and a full biosphere in which to appear. The filter could be at any of these steps, but the steps we do not understand are not evenly distributed. They cluster in the early biology and in the cognitive. And the honest position is to acknowledge that the distribution of our ignorance is not random, and that the steps we know least about are the steps most likely to hide the filter. There is one more step Hansen discussed, the one that comes after us. The filter might not be in the biological history, it might be in the future. It might be something that civilizations reach when they are approximately where we are with nuclear weapons and biotechnology and artificial intelligence in development and climate systems under stress, and international governance structures straining under the weight of coordination, problems they were not designed to solve. It might be that this specific developmental window after technology, before stability, is where civilizations fail. If so, the filter is not a past event that determined our rarity. It is a present condition. It is operating now. And the silence of the cosmos is the track record of every civilization that has entered this window before us. The most important argument in this story, the one that changes how you read the night sky afterward, is not the wow signal. It is not the Drake blackboard. It is not Fermi at lunch. It is the argument about what the filter means for the value of every decision made in the window we are currently in. The philosopher William MacAskill and others in the existential risk tradition have made this calculation explicitly. If humanity survives and eventually spreads beyond Earth, the number of future humans who will exist is potentially enormous, billions of people per year over millions or billions of years. The total number of future people is therefore potentially many orders of magnitude larger than the number of people alive today. If the great filter is ahead, and if the probability of clearing it is, say, 50%, an optimistic figure given the silence, then the expected number of future people is reduced by half relative to the case where the filter is behind us. The stakes of civilizational risk are not the deaths of people currently alive. The stakes are the entire future of intelligence in this part of the universe. Every action that increases the probability of survival by even a small amount has a large expected value when multiplied against that potential future. This is not a comfortable way to think about ethics. It places enormous weight on civilizational scale decisions and comparatively little weight on individual scale ones. It implies that the most important things happening right now are not the things that dominate any given news cycle, but the slow-moving structural questions, the governance of AI development, the trajectory of biosecurity policy, the resilience of international institutions, the probability of nuclear use. It implies that the Petrov question, whether the right person is in the right room when the warning system gives a false alarm, is one of the most important structural questions in human history, and that we have answered it so far by luck, and that luck is not a long-term strategy. This is where the great filter stops being an abstract cosmological argument and becomes something more local, something with a name, a room, a night, a man. There is a man named Stanislav Petrov. He was born September 7, 1939 in Vladivostok. He was a lieutenant colonel in the Soviet Air Defense Forces. He died May 19, 2017, in Fryazevo, a small town outside Moscow. He was 77 years old. He died largely forgotten, in relative obscurity. He had received some recognition in his later years, a Dresden Peace Prize, an appearance at the United Nations, but he was not a household name. Most people who know his story know it because it appeared in a list of people who saved the world that circulates online. On September 26, 1983, Petrov was the duty officer at Serpukhov 15, the Soviet nuclear early warning center located in a secret facility south of Moscow. At approximately midnight, the system reported that a United States intercontinental ballistic missile had been launched toward the Soviet Union. Then 4 more. The system's confidence level was highest. The protocol was clear. Report up the chain. The assumption built into the protocol was that the warning system was reliable. Petrov did not report. He decided in real time, without consultation, without precedent, that the warning was a false alarm. His reasoning: the United States would not begin a nuclear exchange with 5 missiles. If they were going to launch, they would launch everything. 5 missiles made no strategic sense. Also, the ground radar, a separate system, was not confirming the launch. He was right. The false alarm was caused by a specific alignment of sunlight, satellite position, and cloud cover that produced a signal the satellite interpreted as missile exhaust. It happened on one of the most politically tense nights of the Cold War, 3 weeks after Soviet forces had shot down Korean Airlines Flight 007, killing 269 people, raising tensions to a level that U.S. intelligence later assessed as genuinely dangerous. Had Petrov followed protocol, the chain of events that might have followed is not certain. The Soviet response system had human decision points above Petrov. Someone else might have questioned the report. But we do not know. What we know is that on that night, one man made one decision, and the decision was correct. Petrov was not decorated. He was, in various accounts, reprimanded not for making the wrong call, but for improperly filling out his logs, for the procedural violations that necessarily accompanied a decision made outside the protocol. The Soviet system was not designed to reward judgment that went against procedure, even when the judgment was correct. Especially when the judgment was correct, because acknowledging the correctness required acknowledging the near miss, and acknowledging the near miss was embarrassing. Petrov was reassigned to a less sensitive position. He took early retirement. He moved to the apartment in Fryazevo. His wife became ill. He cared for her. She died. He lived quietly. He was rediscovered eventually by journalists and filmmakers. A Danish filmmaker made a documentary about him in 2014. Petrov was by then elderly and uncomfortable with the framing. He said in interviews that he did not consider himself a hero because he had simply done what seemed correct to him in the moment, and that the outcome might have been different if someone else had been on duty that night. He was right about that. The great filter, if it is ahead of us, operates through exactly this kind of moment, not through dramatic, visible, politically acknowledged crisis. Through the night shift. Through the person who is in the room when the system says something that protocol requires treating as real. Through the gap between what the protocol requires and what the situation actually demands. The civilizations that preceded us, if there were any, if the silence reflects their absence rather than their rarity of origin, encountered their own September 26th moments. And enough of them had someone other than Petrov on duty to produce the silence we now measure. That is not a safety system. That is the absence of one. Petrov died in Fryazevo on May 19, 2017. The world did not mark it adequately. The scale of acknowledgement was not proportional to the scale of what he had done. Every person born after September 26, 1983 exists in a timeline that includes Petrov's decision. That is not a figure of speech. That is the structure of what occurred. The world in which you are listening to this is the world that Petrov's judgment produced. And it is a world in which the great filter has not yet declared itself, in which we are still here, still listening, still in a position to do something about what we understand. The nuclear near-miss record extends beyond Petrov. The cases are documented. In 1979, a test tape was accidentally fed into a live NORAD system, generating a 100% probability readout of incoming Soviet missiles. NORAD technicians questioned it. The president's national security advisor was called. No launch was ordered. In 1983, during NATO's Able Archer military exercise, Soviet intelligence misread the wargame as preparation for an actual nuclear first strike, and the Soviet response moved to a readiness level that, according to later accounts, came dangerously close to triggering a preemptive launch. During the Cuban Missile Crisis, a Soviet submarine B-59, cut off from communications, under depth charge attack by American destroyers and operating under the assumption that war had begun, came within one officer's refusal to launching a nuclear torpedo. Two of the three officers required to authorize the launch had agreed to fire. The third was Vasily Arkhipov. He refused. 3 separate nights, 3 separate rooms, 3 separate individuals whose specific judgment, in the specific moment, held the outcome. The margin has existed repeatedly, and has been survived repeatedly, and each survival was partly a matter of the right person being present. That is not a robust safety architecture. That is luck dressed as a system. And the great filter argument, if correct, says that luck is not a long-term survival strategy. Luck is what you have until you don't. Enrico Fermi died in November of 1950, 4 years after the lunch table question. He died of stomach cancer, probably caused by radiation exposure, a cost he had paid without knowing it over the course of building the things he built. He did not live to see SETI become a formal enterprise. He did not live to hear the WOW signal not repeat. He did not live to see the Kepler telescope produce its catalog of habitable worlds, or Breakthrough Listen scan millions of stars, or the silence persist through all of it. He asked the question. He did not get to wait for the answer. Frank Drake spent his life on the search. He was still involved with SETI into his 80s, still engaged with the question, still expressing hope that the answer would come. He died in September of 2022, at 92 years old, at his home in Aptos, California. He did not hear the signal he spent his life listening for. In interviews late in his life, he was clear that the lack of signal did not diminish his belief that the search was right. He remained optimistic. The optimism of a field's founder is not the same as the evidence the field produces. Drake had every reason to believe the signal would come. The signal did not come. Jill Tarter spent decades as the director of the SETI Institute. She is the person Jodie Foster's character in Contact was based on. She has been one of the most sustained, most credible, most publicly articulate voices for the search. She has also been honest about what the search means if it continues to find nothing. The absence of a signal is information, she has said. It is not the information she wanted, but it is information. And the honest response to information is to update. That gap between the best available reason to believe and what the evidence provides is not a failure of intelligence or character. It is the shape of a question that the universe has not yet answered in the way the questioner hoped. Or it has answered it. And the answer is the silence itself. And the silence has been there all along. Here is what the Drake equation says when you fill it in honestly. The rate of star formation, 3 per year in the Milky Way. The fraction of stars with planets, high, probably above half. The fraction of planets that are habitable, perhaps 1 in 5 for sun-like stars. Those numbers give you roughly 300 million potentially habitable planets in the Milky Way. Now the terms we do not know. The fraction of habitable planets where life emerges, unknown. On Earth it happened quickly. That is one data point. If the probability is 1 in 1,000, there are 300,000 life-bearing planets in the Milky Way. If it is 1 in a million, there are 300. If it is 1 in a billion, there are fewer than 1. We do not know where in that range the truth lies. The fraction of life-bearing planets where intelligence emerges, unknown. On Earth, in 4 billion years of life, it happened once. It did not happen in insects, which have been evolving for 400 million years. It did not happen in birds, which are the descendants of theropod dinosaurs and have large brains and complex social behavior. It happened in one lineage of great apes over the last few million years. The conditions that produced it may not be generally reproducible. The lifespan of a technological civilization, Drake called it L, is the term that Sagan was most generous with, and that the great filter argument interrogates most directly. If civilizations reliably destroy themselves within a few centuries of developing dangerous technology, L is small. If L is small, and the number of communicating civilizations right now is small regardless of how large the other terms are. A civilization that lasts 100 years broadcasts a radio signature for 100 years. The Milky Way is 100,000 light years across. A brief civilization is a small candle. When you fill in the terms honestly, not generously, not pessimistically, honestly, the range of n is very wide. It encompasses 1. It encompasses 0. The silence is not consistent with millions. The silence constrains the top end of the range, and the honest center of the distribution, given the silence, is much closer to 1 than to a million. What makes L small? Not a comet strike, not a gamma-ray burst, not a geological event. Civilizations with enough technology can eventually survive or predict natural disasters. What makes L small is something internal, something civilizations do to themselves, or something that emerges from what civilizations are. The thing that terminates a civilization capable of surviving natural disasters is the thing that cannot be protected against by technology, because it is the thing that technology makes possible. That is the filter. Not the universe killing civilizations from outside. Civilizations failing from inside, at the moment of their greatest power and their least wisdom, in the window between knowing how to destroy and knowing whether not to. The silence is loudest in the late part of the night, which is where you are right now, and which is why it is worth saying plainly, this is not an argument for despair, it is an argument for seriousness. Despair would require believing that the filter being ahead means we will fail. The argument does not require that. It requires only that the filter is real and effective, that something stops most civilizations. It does not require that something stops all of them. If even one civilization in the history of the galaxy has cleared the filter, has survived the window, has built the kind of redundancy and duration that makes it permanent, then the argument still holds for the others. And the exception is the thing worth being. We are still in the window. We have not cleared it. We have not failed it either. We are here, at this specific moment, with the understanding that the window exists, and that the choices made in it have stakes we are only beginning to formally account for. Most of the civilizations the great filter hypothesis requires to have existed, the ones whose absence produces the silence, did not have that understanding. They did not know they were in a window. They did not have 60 years of systematic silence to look at and interpret. They did not have Hansen's paper or Bostrom's argument or the accumulated literature of existential risk that has grown in the first decades of the 21st century. We have all of that. We have the record of our own near misses. We have Petrov's story. We have the documentation of every time the system came close to failing and didn't. We have the tools to recognize the problem, even if we do not yet have the tools to reliably solve it. That is something. It is not certainty. It is not comfort. But it changes the shape of the choice. It makes the choice visible, which is the precondition for making it well. The honest answer to the Fermi Paradox, the one that the evidence points toward, the one that the serious literature has been converging on, the one that most public treatments have not said plainly, is this: we are probably alone. Not certainly, probably. And the question of whether we remain alone, whether we are the one data point that becomes two. The first civilization that becomes the civilization that clears the filter and spreads and persists is not a scientific question. It is a choice. Many choices, made by many people, in many rooms, over many years, without most of them knowing that the stakes are what they are. The people who understand the stakes are a small community. They work in existential risk institutes and biosecurity programs and AI safety organizations and arms control think tanks. They write papers that circulate in specialized journals and do not, for the most part, generate the kind of public engagement that Sagan's television series generated. They are not Sagan. They do not have his gift for making the terrifying feel like wonder. What they have is the math. And the math is clear. And the math has been clear for long enough that the failure to communicate it widely is itself a kind of filter, a meta-filter, operating inside the species that most needs to understand it. The universe is not withholding its answer. It gave the answer already. The silence is the answer. And the silence, read honestly, says this: we are either the miracle at the end of an almost impossible journey, or we are the latest attempt at a passage that almost nothing survives. We do not know which. We cannot know yet. We are inside the question, at the exact moment when the question becomes actionable, when we are capable of destroying ourselves, and capable, if we choose correctly, of eventually not being destroyable. The window is open. It has been open for 80 years, since Trinity, since the first test of the first nuclear weapon in the desert of New Mexico on July 16, 1945. When J. Robert Oppenheimer, watching the fireball, recalled the words of the Bhagavad Gita, "Now I am become death, the destroyer of worlds." He was not wrong. He had become something new. We had become something new. A species with the power to end itself. The question the great filter poses, the question the silence poses, is whether becoming that thing is the last step before failing, or the last hard step before something that does not fail. The silence does not answer that. The silence is the record of what has happened to others. Our answer has not been written yet. It is being written now, in the choices being made in the rooms where someone is deciding how to govern an AI system, in the labs where someone is thinking about what to do with a dangerous capability, in the facilities where someone is on duty in front of a screen that might show something that is not what it appears to be, and where the protocol says one thing and the judgment, if it is present and if it is correct, says another. Go back one more time to Petrov. Not the heroic version, the version that happened. He made his decision. He did not report. The false alarm passed. His shift ended. He went home. His decision was discovered by his superiors. He was not celebrated. He was reassigned. He moved to the apartment. His wife became ill. He cared for her. She died. He lived quietly until a filmmaker found him. He was uncomfortable with being called a hero. He said the outcome might have been different if someone else had been on duty that night. He was right about that. And the world that resulted from his being there, this world, the one in which you are listening to this, the one in which the question is still being asked, is a world that contains Petrov's decision in its foundations. Silently, invisibly, the way all the decisions that kept the window open are embedded in the ordinary texture of a world that does not know it nearly wasn't. The silence is the record. We are the latest entry. Whether we are the entry that ends the record, or the entry that finally breaks it, whether we are the last name on a list of failures, or the first line of a different kind of story, is not yet determined. The record has been running for 13.8 billion years. It has recorded so far one civilization that learned to ask what the silence means. We are the ones asking. Whether we are the first, whether we are so rare that no one asked before us, or whether we are asking in the silence left by everyone who asked and then went quiet, we are asking alone. The instruments confirm it. The mathematics of what we should see if others were here, run without hope as a prior, confirms it. The sustained, improved, expanded, decades-long search confirms it. We are asking alone. And the only answer the universe has given, across all that time and all that space and all that listening, is the one it has always given. Nothing, yet, there is a version of this story that ends with the silence and calls that sufficient. That names the filter, maps the candidates, documents the near misses, and then releases the audience back into their evening, with the weight of the argument assembled, but the implications left to settle on their own. Most treatments do exactly this. They deliver the dread and then step back, as though the dread is the conclusion, as though naming the problem is the same as reckoning with it. This is not that version. Because there is a question that the great filter argument raises that almost no popular treatment of it ever reaches, and it is the question that changes the argument from a cosmological observation into something that has a specific bearing on how a person orients their life. The question is not where the filter is. The question is what a species does when it knows the filter exists, knows it might be ahead, and knows that knowing it is ahead is the one advantage no civilization before it demonstrably had. What do you do with that? Not abstractly, not institutionally, not in the passive sense of hoping that the people running the relevant organizations make the right calls. What does a conscious, reasoning person who has now understood this argument, do with the understanding that the silence is data, that the data points somewhere specific, and that the somewhere specific includes the window that is currently open? The honest answer is that most people do nothing. Not out of indifference, not out of denial, but because the gap between understanding a civilizational scale problem and having a legible personal response to it is so large that the mind instinctively retreats to the scale at which action feels possible. The scale of the day, the scale of the week, the scale of what is immediately in front of you. This is not weakness. It is the ordinary operation of a brain built for a world of immediate threats and immediate rewards. Now confronted with a threat whose timeline is generational, and whose mechanisms are institutional, and whose prevention requires sustained coordination across populations that mostly do not think about it. The great filter does not care about the scale at which the human brain is comfortable operating. The filter operates at the scale of centuries, of civilizations, of the specific developmental window between acquiring the technology to destroy yourself and acquiring the wisdom or the structural constraints to reliably not do so. And the question of what a person does with that knowledge is not a question the filter answers. It is a question the person has to answer. And the answer, if it is honest, has to reckon with the size of the gap between understanding and action. Start with what the people who take this most seriously actually do. The existential risk community centered in Oxford, Cambridge, Berkeley, and a handful of other institutions has been growing since the early 2000s. It grew out of a specific intellectual lineage: Bostrom's work on anthropic reasoning and existential risk, Hanson's Great Filter paper, a broader movement in philosophy and economics that took seriously the question of humanity's long-run future and the specific ways it might be cut short. The people in this community are, by and large, not the kind of people who appear in Hollywood disaster films. They are not doomsayers. They are, on the whole, careful, quantitatively sophisticated researchers who have made a professional bet that the question of civilizational survival is tractable, that it can be studied, modeled, and eventually informed by research in the way that other large-scale risks have been. What they actually do, on a daily basis, is closer to what any researcher does than what a doomsday prepper does. They write papers, they build models, they run workshops, they advise governments when governments are willing to be advised. They argue with each other, sometimes bitterly, about questions of methodology and priority, about whether AI is a larger risk than bioweapons, about whether extinction is the only outcome that matters, or whether permanent civilizational collapse without extinction also deserves weight, about how to measure the probability of events that have never occurred and for which there is no historical base rate. The internal arguments are not a sign of weakness. They are what serious research looks like when it is being conducted honestly, and the questions are genuinely hard. The alternative agreement without evidence would be the sign of a community that had stopped doing research and started doing something more like religion. What is striking, when you look at this community from the outside, is not the arguments. It is the seriousness. These are people who have looked at the great filter argument, accepted that it is probably correct in its basic structure, accepted that the filter might be ahead, and then made a career-level commitment to working on it, not as a side project, as the thing, as the central organizing fact of their professional lives. The question of whether humanity survives the next few centuries is, for these people, not a rhetorical question, or a thought experiment, or a conversation topic. It is the problem they are paid to think about. The size of that community relative to the size of the problem is a fact worth sitting with. The existential risk research community numbers, generously, in the low thousands globally. The problem it is working on is the question of whether the only confirmed civilization in the observable universe will survive its own developmental window. The ratio of researchers to problem is, to say the least, not comfortable. Consider the analogy that Toby Ord, a philosopher at Oxford and author of The Precipice, one of the most careful treatments of existential risk in the literature, has used repeatedly in his public work. Ord asks you to imagine that astronomers have detected an asteroid on a collision course with Earth. The impact is not certain. The probability is something like 1 in 6. But 1 in 6 is not small. 1 in 6 is the probability of a bullet in a single-chamber Russian roulette. It is the probability that most people, presented with the choice of whether to pull the trigger, would not pull. And yet we would not. On discovering a 1 in 6 chance of civilizational destruction by asteroid, simply continue with our current activities and hope for the best. We would as a species treat it as the defining challenge of the moment. We would redirect resources. We would build institutions. We would make it the organizing priority of international cooperation in a way that would make every other geopolitical dispute seem secondary. Ord's argument is that the current probability of civilizational catastrophe from causes within our control, from nuclear weapons, from engineered pathogens, from misaligned AI, from the interaction of these risks under conditions of geopolitical stress, is at least as large as 1 in 6 over the current century, possibly larger. And we are not treating it as the defining challenge of the moment. We are, as a civilization, doing something closer to continuing with our current activities and hoping for the best. The reason the asteroid analogy is useful is that it separates the question of probability from the question of response. The asteroid probability of 1 in 6 would generate an enormous response. Because asteroids are legible, they are objects, they are visible, their trajectories are calculable, their threat is unambiguous and undeniable. The threats that Ord is cataloging are less legible. They are distributed across institutions, across timelines, across technical systems and geopolitical dynamics that are genuinely complex and genuinely uncertain. The probability estimates are contested. The mechanisms are not as visually obvious as a rock approaching on a calculable path. And so the response is not commensurate with the risk, because the risk is hard to see in the way that a rock is easy to see. The great filter argument adds something to Ord's asteroid analogy. It adds the observation that this disproportion between risk and response is not new, not specific to our moment, and not obviously correctable by more information. Every civilization that has existed, if any have existed, faced the same disproportion. The legible threats got responses. The illegible ones did not. The illegible ones were the ones that ended the civilizations. And the civilizations did not survive to generate the data that would tell us exactly what they were. We are not reading a history of civilizational failures. We are reading the silence that the failures left. And the silence is exactly the shape that a consistent disproportion between risk and response, reproduced across every civilization that has reached this window, would produce. There is a concept in game theory and decision science called the tragedy of the time horizon. It describes the systematic failure of agents, individuals, organizations, nations to adequately weight outcomes that occur far in the future relative to outcomes that occur immediately. It is not irrationality in the technical sense. It is a predictable consequence of the discount rates that agents apply to future outcomes, rates that are shaped by evolutionary pressures, by institutional incentive structures, by the simple fact that the future is uncertain in a way that makes heavy investment in it feel irrational, even when the expected value calculation clearly supports it. The tragedy of the time horizon is visible everywhere in the history of civilizational risk management. Nuclear non-proliferation is a long-horizon problem. The payoff of successful non-proliferation is the non-occurrence of nuclear exchanges decades or centuries from now. And the cost is real and immediate in the form of diplomatic constraints, economic restrictions, and the political capital required to maintain international agreements against the constant pressure of national interest. The payoff of defecting from non-proliferation is more immediate: strategic advantage, deterrence credibility, domestic political gains. Every nuclear proliferation event in history can be understood as a tragedy of the time horizon. The immediate benefits of acquisition outweighed in the decision-making of the acquiring state. the long-term costs to civilizational stability. Biosecurity is the same structure. The investment required to build robust global pathogen surveillance systems, to regulate dangerous research, to maintain the international agreements that reduce the probability of engineered pandemic, is immediate and tangible. The benefit is the non-occurrence of something that has not yet happened, in a future that is uncertain, to populations that do not currently exist. The time horizon tragedy predicts underinvestment, and underinvestment is what we observe. Climate change is the same structure extended over longer timescales. The costs of decarbonization are immediate. The benefits are distributed across decades and centuries. The people who bear the costs are not, in the relevant time frame, the people who receive the benefits. The tragedy of the time horizon is baked into the structure of the problem in a way that makes collective action against it genuinely difficult, even when the evidence is overwhelming and the political will is present. The great filter argument suggests that the tragedy of the time horizon might be the filter. Not nuclear weapons specifically, not engineered pathogens specifically, not any single technology or failure mode, but the structural property of civilizational decision-making that consistently underweights long-horizon risks relative to short-horizon rewards. A property so consistent, so deeply embedded in the dynamics of how complex adaptive systems make collective decisions, that it operates across every civilization that reaches the relevant threshold. A meta-filter. A filter not on any specific technology or behavior, but on the capacity to organize adequately against threats that are large, real, and temporally distant. If this is correct, the problem is not solvable by more information. More information about the risk does not reliably close the gap between understood risk and adequate response, because the gap is not produced by lack of information. It is produced by the structure of how information about future risk is weighted against the demands of the present. The people who run the nuclear early warning systems know exactly what the stakes are. They knew on September 26, 1983. The system still produced a false alarm that came within one person's judgment of triggering a catastrophe. Information was not the variable. Decision architecture was the variable. And decision architecture is shaped by institutional incentives, by protocol, by the specific design of systems built to manage specific risks, under specific assumptions. Assumptions that do not always match the situations those systems encounter. The question that the great filter argument eventually forces is a question about what kind of species we actually are, separate from what we would prefer to be. We are a species that has, in 200,000 years of anatomical modernity, produced agriculture, writing, mathematics, philosophy, scientific method, the Industrial Revolution, the germ theory of disease, nuclear physics, and the ability to sequence and edit the genome. We have done all of this in an eye blink by the standards of geological time. The acceleration is real and is accelerating. The gap between the technology we had in 1900 and the technology we have now is larger than the gap between the technology of ancient Rome and the technology of 1900. The gap between the technology we have now and the technology we will have in a century, if we are here in a century, is likely larger again. We are also a species that has fought 2 world wars in the span of 30 years, that has maintained a nuclear arsenal capable of ending industrial civilization for 80 years without being entirely certain it will never be used, that is currently unable to coordinate adequately on climate change despite near universal scientific agreement on its trajectory, and that is developing artificial intelligence systems of increasing capability without having solved the alignment problem to the satisfaction of the people who understand it best. Both of these things are true simultaneously. We are extraordinarily capable and demonstrably bad at organizing ourselves around long-horizon risks. We are the product of evolutionary pressures that built excellent machinery for navigating immediate social threats in small groups. And we are now attempting to use that machinery to navigate existential risks that operate across timescales of decades and centuries, and through institutions of unprecedented complexity. The mismatch is not incidental. It is structural. This is not a pessimistic reading. It is an accurate one, and accuracy is what the great filter argument demands, because the filter does not respond to optimism. It responds to what we actually do with the window we are in. The distinguishing feature of our moment, the thing that is genuinely different from the situation of any civilization that might have preceded us, is that we have the conceptual tools to name this mismatch. We can see the tragedy of the time horizon. We can identify the decision architecture failures that produced the near misses. We can read Petrov's story not as a miracle, but as a data point about institutional design, and ask what institutional design would not have depended on Petrov. We can look at the great filter argument and understand that the filter might be precisely this: the gap between knowing what needs to be done and being organized in a way that does it. Knowing the gap exists is not the same as closing it, but it is the precondition for closing it in the only way that could work, which is deliberately, through the deliberate redesign of the institutions and incentive structures that currently produce the mismatch. Not through hoping that the right person is in the right room, through building systems in which the outcome does not depend on who happens to be in the room. The specific institutional changes that the existential risk community has argued for are worth naming, because they are concrete in a way that the abstract argument is not. On nuclear risk, the argument is not for disarmament in the immediate term. The geopolitical conditions for mutual disarmament do not currently exist, but for specific technical changes that reduce the probability of accidental or unauthorized launch. Launch on warning, the doctrine that allows nuclear weapons to be launched based on warning system data before an attack is confirmed by impact, is the specific policy that the Petrov scenario exploited. Eliminating launch on warning, or replacing it with a policy of retaliating only after confirmed detonation, would have made Petrov's decision irrelevant. It would have removed the single point of human judgment failure mode from the most dangerous moment in the system. This is not a fantasy. It is a policy change that has been argued for by former secretaries of defense, former nuclear command officers, and arms control researchers for decades. It has not been adopted, primarily because the military doctrines of the relevant states treat the speed of response as a strategic asset. The strategic case for launch on warning is real. The civilizational case against it is also real. The two cases have not been adequately weighed against each other in any public forum. On biosecurity, the argument centers on the governance of dual-use research that advances legitimate scientific goals while simultaneously producing knowledge or materials that could be misused. The specific concern is gain-of-function research that deliberately enhances the transmissibility or virulence of pathogens in order to study them. This research has legitimate scientific justifications. It also produces exactly the kind of enhanced pathogen capability that the biosecurity community identifies as a civilizational risk. The governance structures that currently regulate this research vary by country, are largely self-policing within the scientific community, and have not kept pace with the technical capabilities that the research itself has produced. International agreements on biological weapons exist. The Biological Weapons Convention, in force since 1975, but they have no formal verification mechanism. There is no international inspection regime for biological weapons comparable to the inspection regime that exists for nuclear weapons. The absence of verification is not an oversight. It reflects the genuine difficulty of distinguishing defensive from offensive biological research. It also means the governance structure is substantially weaker than the risk profile of the technology warrants. On AI, the argument is about the timing and structure of capability development relative to alignment research. The concern, stated plainly by researchers who work on this problem, is that the development of AI systems with capabilities significantly exceeding human performance across a wide range of domains is proceeding faster than the development of reliable methods for ensuring those systems pursue goals that are aligned with human values and interests. The gap between capability and alignment is the risk surface. What would close the gap is either slowing capability development to allow alignment research to catch up, or accelerating alignment research to the point where it is ahead of capability development. or some combination. What is currently happening is neither. Capability is advancing rapidly under competitive pressure from both commercial and national actors. And alignment research, while growing, is not growing at a commensurate rate. None of these institutional changes are politically simple. None of them are achievable by one actor or one nation. All of them require the kind of sustained international cooperation that geopolitical competition makes difficult, and that the tragedy of the time horizon makes easy to defer. This is precisely the shape that the Great Filter would take if it is operating through institutional failure rather than through any single catastrophic event. Not a bang. A persistent structural inability to build the cooperation required to manage the tools that the same civilization's ingenuity produced. There is an objection that sophisticated audiences raise at this point in the argument, and it is worth addressing directly because it is not a weak objection. The objection is this. The Great Filter argument assumes that the absence of detectable civilizations in the observable universe is evidence about what happens to civilizations in general. But our observable universe is a specific region of space and time, and our search of it is incomplete, and the specific conditions of our galaxy, the stellar population, the age, the chemical composition, may not be representative of the conditions under which civilizations elsewhere might arise. The silence might be a local fact, not a universal one. The filter might be specific to certain types of galaxies or certain epochs of cosmic history, and we might be making a broad claim about civilizations from a sample that is not representative. This is a real objection. It deserves to not be dismissed. And the honest response to it is that the objection is correct in one sense and insufficient in another. It is correct that our observable universe is a specific region with specific properties, and that extrapolating from local silence to universal filter requires assumptions about uniformity that cannot be fully verified. The objection has genuine epistemic weight. It is insufficient because the scale of the observable universe is enormous enough that the local versus universal distinction begins to lose force. The observable universe contains 2 trillion galaxies. If the Milky Way and its local group are unusually quiet, if there are other regions of the universe with abundant, detectable civilizations, those regions are sufficiently far away that their signals have not reached us, which means they could not have colonized our region either, even at the speed of light, over the age of the universe, if they are far enough away. The filter is therefore at minimum a filter on our accessible cosmic neighborhood. And a filter on our accessible cosmic neighborhood is all that matters for the question of whether we are going to encounter other civilizations, which is the question the filter argument is actually about. The objection does, however, reinforce something important. The Great Filter argument is a probabilistic argument operating under deep uncertainty, not a deductive proof. It is the best reading of the available evidence. The best reading might be wrong. Absence of evidence is not proof of absence, and 6 decades of SETI, however impressive relative to previous search capability, is a genuinely small coverage of the observable universe. The argument should be held with appropriate epistemic humility, which is to say, it should be taken seriously as the most evidence-consistent position, while remaining open to revision if new evidence changes the picture. What new evidence would most change the picture? Detection of an artificial signal, discovery of intelligent life, or its remnants, anywhere in our vicinity. Detection of megastructures or large-scale engineering signatures around any star in our galaxy. Any of these would dramatically revise the probability distribution on the filter's location in exactly the way that the Bostrom-Mars argument describes. Each positive result narrows the filter forward. Each narrowing increases the urgency. The specific texture of the window we are in, the particular combination of risks and capabilities that defines this moment, is worth describing in more detail than the argument usually permits, because the details matter for understanding what clearing the filter would actually require. We are, right now, in a period of simultaneous acceleration across multiple technological domains that each independently generate existential risk. Nuclear capability has been present for 80 years, and has, through a combination of deterrence doctrine, arms control agreements, close calls narrowly avoided, and the sustained judgment of individuals in specific rooms not been used in warfare since 1945. That track record is real. It is also, when viewed from the perspective of the Great Filter argument, a track record of 80 years, which is not a long time against the civilizational timescales the filter operates on, and which was generated under specific geopolitical conditions, two superpowers, roughly symmetric capability, mutual assured destruction as the operative deterrence framework that are currently changing. The number of nuclear-armed states has grown. The deterrence framework of mutual assured destruction is less clean when applied to asymmetric conflicts or to states with different thresholds for nuclear use. The specific conditions that produced 80 years of non-use are not guaranteed to persist. Biological technology is accelerating in ways that are genuinely unprecedented in their combination of accessibility and power. The time and cost required to synthesize a pathogen from scratch has fallen dramatically over the past 2 decades and continues to fall. The knowledge required to do harmful things with that synthesis capability is increasingly available in the scientific literature, which is globally accessible in a way that enrichment centrifuges and fissile material are not. The governance structures for this technology have not kept pace. The gap between what a small, knowledgeable, motivated group could do and what the current governance structures are designed to prevent is larger today than it was 10 years ago, and the trajectory suggests it will be larger in 10 years than it is today. Artificial intelligence is a third acceleration, and it is the one whose risk profile is most genuinely uncertain in its specific mechanisms, while being clearest in its general shape. AI systems have, over the past several years, demonstrated capabilities in reasoning, language, scientific analysis, and autonomous action that were not widely predicted on the timelines they arrived. The rate of capability improvement has been faster than many researchers expected. The alignment research community, the people working on ensuring that advanced AI systems pursue goals compatible with human welfare, has made progress, but not progress that clearly outpaces capability development. The specific question of whether we will develop AI systems with broadly superhuman capabilities before we have reliable methods for ensuring those systems are safe is genuinely unresolved. The people who think the answer is yes are not fringe thinkers. They include researchers at the major AI development organizations who have looked at the trajectory of their own systems and found the timeline concerning. These 3 accelerations are not independent. They interact. AI capability accelerates biological research, which accelerates the design space for dangerous pathogens. AI capability accelerates cyber warfare, which introduces new attack surfaces into the command and control systems of nuclear arsenals. Climate stress increases geopolitical competition over resources, which increases the probability of the kinds of great power conflict that most directly raise nuclear risk. The risks are a system, not a list. And the system has properties that the individual components do not. Specifically, the property that managing any one of them requires the kind of sustained international cooperation that the other risks are simultaneously making more difficult. This is the window. This specific combination, at this specific moment, with this specific set of capabilities, and this specific set of governance deficits. The window is not infinitely wide. Technology will continue to develop in ways that both increase the risks and potentially provide tools for managing them. AI that creates biosecurity risks also creates biosecurity monitoring capabilities. Space technology that offers civilizational redundancy, the ability to spread human presence beyond a single planet, removing the single point of failure that our current confinement to Earth represents, is being developed alongside the risks that make that redundancy urgent. The window closes in one of 2 ways. We build the governance structures and the institutional capacity to manage these risks reliably before the risks exceed our management capacity, or we don't. The Great Filter says that most civilizations that reach this window don't. The science says it. The mathematics says it. The specific near misses in our own track record say it. And the question that remains, the only question that remains, and the one that the universe is currently waiting on, is whether we are the exception. Return one final time to the night sky. It looks the same as it did before you understood any of this. The stars are the same distance away. The darkness between them is the same darkness. Orion stands where he has always stood, and the Milky Way arcs where it has always arced, and the specific photons that are arriving at your eyes from the most distant visible stars departed those stars before complex life existed on this planet. Nothing has changed that a telescope could measure, and yet the sky is not the same. Because what you know about the silence that fills it has changed, and knowledge changes the meaning of what you are looking at, even when the thing itself is unchanged. The sky is now not simply dark between the stars. It is specifically evidentially dark. Dark in the way that a room is dark when you have looked carefully and found no one in it. Dark with a darkness that is the answer to a question rather than merely the absence of light. There is a word for the feeling this produces that does not translate well into English. The Japanese concept of mono no aware, the bittersweet awareness of impermanence, the recognition that the beauty of a thing is inseparable from its transience, gets closer than most. The sky is beautiful. The universe is vast and ancient and full of the ingredients of complexity. And we are here, briefly, in a universe that produced us and has not demonstrably produced anyone else, looking up at the record of our solitude and finding it remarkable rather than crushing. Finding it, despite everything, worth the looking. That response, the response that finds worth in the looking even having understood what the looking reveals, is not denial. It is not the comfort of turning away. It is the harder thing, staying with the view, with the silence included, and finding that what is there is still worth being here to see. We are, by any measure, an improbable thing. The specific sequence of contingent events required to produce a species capable of asking cosmological questions is long and fragile, and could have been interrupted at any of 100 points in its 4 billion year running. The eukaryotic merger might not have happened. The Chicxulub impactor might have hit differently, or not at all, leaving the dinosaurs to continue for another 100 million years, while our mammalian ancestors remained small and nocturnal and intellectually constrained by their ecological niche. The specific lineage of hominids that developed language might have gone the way of Homo naledi and Homo heidelbergensis, and the dozens of other hominin species that arose and ended without producing the recursive symbolic cognition that makes this question askable. Any of those alternatives, and we are not here. The question is not asked. The sky is dark and silent in the way it has been for 13.8 billion years, without anyone to notice that it is dark, or to find that darkness strange. That we are here to find it strange is, depending on your prior, either a miracle or a lottery result or a selection effect. But it is, undeniably, a fact. We are here. We are asking. And the asking is, in the universe's accounting, a genuinely rare event, rare enough that 60 years of listening to the full sky has not found anyone else doing it. The weight of that rarity is the weight of the entire argument. It is what makes the filter not merely interesting, but urgent. If we were one of millions of civilizations asking the question simultaneously, our specific failure would matter less. The question would persist even if we did not. But if we are one, or nearly one, then our failure is a different kind of event. It is not a species going extinct in the way that species go extinct subsumed into the statistical background of a biosphere's ongoing churn. It is the question going silent. The universe is one confirmed instance of the capacity for cosmological self-reflection, ending before it has had enough time to become something durable. That is what the filter threatens. Not just human lives, as precious as human lives are. The conversation. The long, improbable, 4 billion year project of matter becoming aware of itself and finding the awareness strange and worth investigating. The project that is, as far as every instrument we have ever built can determine, happening exactly once. The last thing to say is the simplest, and it has been earned by everything that came before it. We know something that no prior generation of humans knew with this specificity and this evidential weight. We know that civilizations probably fail in the window between acquiring dangerous technology and acquiring the wisdom to manage it. We know this because the universe has been running for long enough, and has been large enough, and has had the conditions for complexity for long enough, that any other conclusion requires the silence to be something other than what every honest reading of it suggests it is. We know the window exists. We know we are in it. We know the track record is not encouraging. We know the specific mechanisms by which the failure tends to come, not from outside, not from asteroids or gamma-ray bursts, or the indifferent physics of a cold universe, but from inside, from the gap between what we can build and what we can govern. And we know this is the part that is genuinely new, that knowing all of this is the precondition for doing something about it, that does not depend on Petrov, that builds systems rather than relying on individuals, that treats the long horizon risks with the seriousness that a 1 in 6 chance of ending the question deserves, that organizes international cooperation around the risks that international competition is simultaneously making more dangerous. Whether we will do that is not determined. Whether any civilization has done it is, if the great filter argument is correct, an open question whose most honest answer is probably not yet, and whose answer in our specific case is still being written. The silence is waiting. It has been waiting for 13.8 billion years. It will record whatever we become the exception that cleared the filter, the latest entry in a long list of near misses that finally ran out of Petrovs, or something in between that the silence will describe in its own precise, instrument-confirmed, eloquent way. The silence describes things precisely. It has been describing our solitude with perfect accuracy for as long as there has been anyone to listen. We are still listening. We are still here. For now, that has to be enough to work with. For now, that is everything.